Okay, today is Thursday, October 1st, and so this goes for October 1st and October 2nd, Thursday and Friday classes. Wave interaction notes. So some big words to know are these first ones that you come across. So diffraction. Notice that I underlined some of the key parts in the definition of diffraction. So you've got the bending and scattering of a wave as it hits an object or goes through an opening. So when a wave hits an object like the rock wall, it either bends or it goes through an opening. So it either bends and scatters if it hits the rock wall and goes other places, or if it finds a little opening in the rock wall, it's going to go through that opening and then scatter. Okay, so diffraction is that bending and scattering of a wave. Transmission is the passing of a wave through an object. So transmission, like light waves going through glass. So transmission is going through an object. Reflection is about bouncing of a wave after it hits an object. So bounces off of a wave. Reflection, so this is like the mirror. The light waves hit the mirror and then bounce off and return back. So it bounces off after it hits an object. Absorption keyword is taking in. The taking in of a wave by an object as the wave hits the object. So absorption, like light waves are absorbed by darker colors and then the heat increases, the temperature increases. So taking in is that absorption. Refraction is the bending of a wave as it passes through one medium to another. So notice here that refraction is the bending and diffraction is also the bending. So the difference is refraction is the bending as it passes from one medium to another, and diffraction is bending and scattering as it hits an object. So a little bit different there, but they are both bending their light. One example that was given is that ocean waves bounce off the rocks and scatter, and so this is called diffraction, when it bounces off or bends and then scatters into different directions. That's diffraction. All right, moving on to some more examples that she gave us as we went through. So remember that any of these extra notes, these are great to have because when she's talking, she might give other answers, or when she's giving examples on her screen or writing those notes, those are really good extra notes to have written down for the assignments and the quizzes. Okay, so absorption. Absorption, remember, that's when it gets taken in. So dark objects absorb light waves more, and this is what makes you warmer. So if you're wearing like a black shirt versus a white shirt, and you go out in the sun, you're going to be warmer because that dark object absorbs more of those light waves. This is also true for like cement or sidewalks. Those objects are going to absorb that heat more. So sidewalks get a lot hotter because of that absorption of the light waves. Transmission is the passing of a light wave through an object. So again, that key word of through the object. Light waves pass through glass. Sound waves go through the air. So if they're moving through or passing through. So two of those key words for transmission. This one's a great diagram here for reflection. Bounces off, so that keyword of bouncing back. This is our mirror, right? Light waves reflect off of a mirror so that you can see yourself. So the light wave bounces off the mirror and then bounces back. We're going to talk about why it does this directional change in the next slide. Refraction, so remember refraction is one of the ones that says bending. So when light bends is when it goes from one medium to another. So say this is air, and so you have the light waves traveling through the air, and then at this point they move into the water, and that makes the light waves change speed and direction. So that direction is now going this direction, and the speed also changes. You can do a really easy example of this, of having a clear glass or cup, putting some water in it and putting a straw or a spoon, and then getting down eye level. She gave that example in the video. Get down eye level, and you should actually see that straw or spoon. It looks like it has a bend in it. Another example of this is if you've ever swam and tried to grab something underwater. If you try to reach down into the water, it appears that the object is right there, but you miss it and you can't actually grab it. You have to move your hand over a little bit. Because of this change in direction and speed, it looks like the object maybe is right here, but then in actuality it's over a little bit because of this refraction, the changing and bending of the light waves. Another really great example is light from going through a prism or a diamond or any kind of those reflective, refractive types of material. So diamonds have those cuts. Prisms are also like that. They're a triangle, but in a 3D shape. And when light hits them, it refracts that light. It bends it as it goes from the crystal back into the air. And so you see that rainbow type pattern. And that again is from refraction. Our last one again is diffraction. So diffraction is the bending and scattering of the wave. So for example, with our ocean wave is coming in, it hits this rock wall, but it finds a little hole in the wall where those waves can squeeze through that little hole. So that wave has to squeeze through, and then once it gets out on the other side, it scatters in all the area because it had to squeeze through that little hole, and then it scatters out. So those are some examples of our different ways that waves interact. The other part of, nope, I'm sorry, I'm still talking about those ones again. So back to reflection. Reflection, there's the incident wave. This is the wave, the light wave that is going into the mirror, and then it hits the mirror, and then you get a reflected light wave back. So it goes in and then reflects back. When you're talking about reflection, the wave actually changes direction because it's going this way towards the mirror, and then it bounces back and changes that direction back at you. One thing about reflection, when it's reflecting off of things, the angle is equal. So this was one concept she talked about. Angle is equal. So if this angle of the wave going in is at 45 degrees, then the angle that the wave comes back out is also 45 degrees. With refraction, the little picture on the previous page was probably much better, but I tried to recreate it where this wave is going in. So say this wave's maybe in air, and then it hits the water, and it's going to change your speed and direction as it goes. Diffraction, back to our ocean wave here. The ocean waves are coming in. So here's our little opening. That water has to squeeze through it, but as it squeezes through, it's going to bend, and then it's going to scatter out in all directions as it squeezes through that little opening, and that is called diffraction. So again, your keywords of bending and scattering for diffraction. Okay, then it took us to what happens if waves actually interact. So back on this one where we were talking about the diffraction, the transmission, reflection, absorption, refraction. This is when waves interact with an object. Okay, so how do waves interact with an object? That is these 5 keywords here. But when waves interact with another wave, then we get either constructive or destructive interference. So we get interference is what it's called. Interference when the two waves meet. Okay, so our first choice is constructive. So think about when you're constructing something, you're building something up, like a building or a house. So you're making it bigger when you do construction. And that is the point of constructive interference. That is when the crest of one wave either overlaps with another crest or the trough overlaps with another trough. So you've got these two waves here. And when you have constructive interference, then the resulting wave is much bigger. And because it's bigger, it's got a bigger amplitude, you also have energy increasing. So think of constructive interference as putting these two together and creating a big, huge wave. If you're in the ocean and this is happening, two waves headed towards each other, you have two choices. You can either construct them or they construct each other. They smash into each other and they create this big, huge, gigantic ocean wave that you don't want to be caught in the middle of. So that's one choice. Big, huge waves created when they run into each other. The other choice is destructive interference. With destructive interference, they actually make each other smaller or completely cancel each other out. So this is when these two waves, they meet, and when it's destructive interference, the crest of one wave overlaps with the trough of another, and so it ends up being either a smaller wave or completely canceling each other out. So two choices there, either constructive, making it bigger, or destructive, making it smaller. Last page for wave interactions. These are some additional notes that I wrote while doing the assignment or the quiz. A couple things that kind of really stuck out to me. This first one, this is like the very first slide on the assignment. Waves interact with objects and other waves. I wasn't really sure where to get this information. I had to go back in and look through my notes, but I finally found it because this was the topic of this whole lesson. So waves interact with objects and other waves. Transmission, this is another good diagram that was shown on one of the slides. When you have transmission, so say this is the glass, so that light wave is coming through and it goes through the glass because it's transmission, but it slows down so it doesn't go quite as far. It slows way down with transmission. Absorption, one of the examples, heating the sidewalk, wearing a dark shirt, things like that, absorb different waves. Reflection, we talked about the mirror, but then the other one that they came up with was echolocation, and that is a great example of reflection. When you have echolocation, the things like dolphins and bats, they send their sound waves out, and those sound waves bounce off of an object and then can bounce back to them and tells them how far away something is, like food or rocks, things like that. Just a couple of other little notes from doing the assignment that I felt were worthy of writing down. Waves interact with other waves, and that causes interference, which is either your constructive or destructive interference. And then waves hit an object, and then the reflection occurs and bounces off when waves hit an object. When we were talking refraction and diffraction, both of these are bending of waves. So they both have that keyword bending. The difference, remember, between these two is refraction is bending through a medium, so like air, then going into water, where diffraction is bending and then scattering, like going through a little hole, and then the water waves are able to scatter out on the other side. And last thing, anytime amplitude is changed, you have that change in energy, so constructive interference increases that amplitude, destructive interference decreases that amplitude. All right, hopefully me going back through these notes and you can pause and write some stuff down will help on your quiz. Good luck.